Types of functions. First type is constant function. Fx equals to k, where k is a constant. Its value, whatever value we put in place of x, output is always this k. So that's why we can put any real values in place of x. So that's why its domain is set of real number and its range is k. So we take some examples for constant function. Fx equals to 2. In this one, range is only 2. In second example, fx equals to -3, its range is -3. So once we plot its graph, it is always parallel to x-axis. It may be above the x-axis or it may be below the x-axis. Next function is identity function. Fx equals to x. Whatever we put in place of x, the same output we get. That's why its domain is set of real number. Its range is also set of real number. Its graph is like this. If we put positive value of x, we get positive value of y. So we are in first quadrant. We put a negative value of x, we get negative value of y. So we are in third quadrant. It always passes through the origin. Next function is polynomial function. Fx equals to a naught plus a1x plus a2x square up to an x to the power n. So in this polynomial, we can put any real value of x, and so that fx is also real. So its domain is set of real number and its range is also set of real number. So we take one example. Fx equals to 2 plus 3x. In this one, maximum power of x is 1. So that's why this is a linear polynomial. Or once we draw linear polynomial, it is always a straight line. Second polynomial we are taking, fx equals to 1 plus 2x square. This is a quadratic polynomial. Once we draw quadratic polynomial, it is always a curve. Similarly, we can take a cubic polynomial also. Next polynomial is rational function. Rational function is fx equals to gx upon hx. So there are two polynomial. One is in numerator, second is denominator, and denominator polynomial should not be equal to 0. So it's depends upon the function. So we are taking some examples of the rational function. X square upon x plus 3. X plus 3 in denominator, if we put in place of x minus 3, this is not defined. Then fx is not real if we put x equals to -3. So that's why its domain is all real number except -3. Its range is always set of real number. Its range is depend upon the given function, but it will be always set of real number, subset of real number. Once we draw its graph, now reciprocal function. Reciprocal function is fx equals to 1 upon x. Fx equals to 1 upon x. We put any value in place of x, we get fx real, but we put x equal to 0, then fx value is not real. So that's why its domain is all real number except 0. Range is also all real number except 0, because there is no value of x for which we get fx is 0. So its range is fx equals a real number except 0. So its graph is this. It is symmetric in first and third quadrant. Once we increase the value of x, the value of y decreases. Next function is modulus function. Fx equal to mod x. This is the way algebraical expression of the modulus function. Whatever value we put in place of x, we get real value of fx. So therefore its domain is set of real number. Its output is always positive. So its range is 0 to infinity and its graph is this. We put positive value of x, we get positive value of y. If we put negative value of x, we get positive value of y. The modulus graph is always V-shaped graph. Next function is greatest integer function, or we say it's floor function. Fx equals to, this is square bracket of x. This is the algebraical expression. Any real value we can put in place of x, but its output is always integer. Its output is always integer, and we are putting some values in place of x. We are putting some values in place of x. If we are putting 1, the output is 1. If we are putting integer we get. If we are not putting integer as 1.1, then we get maximum integer left to the given number. So maximum integer left to 1.1 is 1. That's why output is 1. Next, if we are putting 0, integer we are putting, we get integer. If we are putting 0.3, this is not integer, then we get maximum number left to 0.3. So maximum integer left to 0.3 is 0. So that's why we are getting 0. Next, we are putting 4. If this is integer, so we get integer value 4. 4.5, this is not an integer. So we get maximum integer left to this 4.4. So it is 4. Its graph is like this. We are putting value from 0 to 1, always we get 0. If we are putting value from 1 to 2, always we get 1. If we are putting value 2 to 3, always we get 2. If we are putting value from 3 to 4, we always get 3. And if we are putting value from 0 to -1, it is always -1. So this type of graph comes, and it is steps. In this graph we observe steps. Next function is Signum function. Its algebraical expression is modulus x upon x if x is not equal to 0, or 0 if x equals to 0. Another way to write this one is 1 if x is greater than 0, 0 if fx is 0, -1 if x is less than 0. Suppose we are putting 3 in place of x. The mod of 3 upon 3, it is 1. If we are putting -1 in place of x, it is -3 modulus is 3, and -3 it is -1. Its domain is set of real number. We get always set of real number, and its output is only these three number: -1, 0, and 1. Its graph is like this. If we are putting positive value of x, it's always give 1s. 1. If we are putting negative value of x, it always give -1. And if we are putting 0, it gives 0. So that's why 0 is dark, and this is undark surface. Thank you.